The Sun, the parent star of our solar system. The Sun is our local star. It produces light and heat from its fusion reactors, which means we can survive. Without the Sun, humanity could not survive. It's 4.5 billion years old. The diameter is 2,250,000 kilometers. Look at this. This is Ulysses. Not much was known about the Sun's polar regions as they aren't visible from Earth. Over the Sun, this allows us to see the poles for the first time, teaching us a great deal about the Sun's magnetic fields. Look at the Sun. Looks pretty cool. It has different layers. Look. The photosphere, the convection zone, the radiation zone, the core. The photosphere is the uppermost layer of the Sun. The only objects above it are the chromosphere and corona. The photosphere has a temperature of 5,000 degrees Celsius, which is hot enough to vaporize every substance known to man. The convection zone works by transferring the plasma built up by fusion reactors via convection. This creates a circular convection current in which heated plasma rises and then cools and shrinks. The radiation zone. The radiation zone of the Sun is where energy from the core and fusion reactors flood through after being created. The core of the Sun operates at a temperature of 14 million degrees Celsius. This makes it hot enough for energy generating nuclear fusion reactions to take place. Fusion is a term used when atoms fuse together instead of being forced apart. Mercury, the first planet in our solar system. Mercury is the closest planet to the Sun. The only spacecraft to ever visit Mercury was Mariner 10. It made 3 passes and mapped most of Mercury's surface and is still in orbit around the Sun now. Mariner, the only spacecraft to map Mercury and Venus. It stopped communicating in 1975 after its liquid nitrogen tanks ran out, causing the probe to pitch and roll out of control. Mercury is pretty nice. Mercury only has 4 layers: the atmosphere, the crust, the mantle, and the core. Mercury's atmosphere is a very thin layer and mainly helium and sodium. It is a quadrillionth of Earth's atmosphere, meaning it has one of the thinnest atmospheres in the entire solar system. The crust. Mercury's crust is slightly thicker than that of Earth's. When Mercury was formed, its core cooled and shrank, resulting in the crust becoming deformed and buckled. This crust wrinkle ridges along its surface. The mantle. Mercury's rocky mantle covered its oversized core. Due to Mercury's size and makeup, any object hitting it would create a ripple effect on the other side. The core. Mercury's huge core is primarily made up of iron and nickel. Its core is creating a dynamo effect inside the planet, giving Mercury a magnetic field, although it is a weak one, more than 100 times weaker than Earth's. Venus, Earth's sister planet. Venus is almost the same size as Earth, but it's closer to the Sun and completely covered with a layer of thick, toxic clouds that affect slightly away from its surface. Venus has suffered from a runaway greenhouse effect. This makes it the hottest planet in our solar system. The Magellan Orbiter, even though it is pieced together out of spare parts from the Viking Voyager, Galileo, and Ulysses probes, it has already mapped Venus and continues to orbit the planet ever since its launch. Venus, red planet. It has 3 layers plus the atmosphere. Venus's atmosphere is made up of mostly unbreathable carbon dioxide, mixed with sulfur compounds that float in the air as clouds and haze. Venus has an atmospheric pressure 90 times greater than that of Earth. The crust. Venus's crust and surface is the closest place to hell in our solar system. It has a lifeless volcanic world, and if a human was to touch down on the planet, they would simultaneously be suffocated, crushed, roasted, and burnt by acidic rain. Venus' rocky mantle extends down roughly 3,000 kilometers, but the moment there is no way of knowing what this mantle is made of, as no probe has survived for more than 1 hour on the surface. The core. Venus's core is made from a mix of iron and nickel, just like our own planet, but it does not create a magnetic field. Earth, our home. Earth is home to humans, us. This planet is the most varied out of the entire solar system, and so far no planet we have found is like ours. We use Earth as a home base to further our understanding of the universe and why we are here. Galileo. The Galileo space probe used Earth's gravity to shoot towards Jupiter, but before it left, it came within 960 kilometers of the Earth's surface and took some very close-up shots of Earth and Moon. So that took some pictures of the Earth. That's how we got the pictures. Earth. The atmosphere, the crust, the mantle, the core. The atmosphere, Earth's atmosphere, is unlike any other in the solar system. It is made up of different zones: the troposphere, stratosphere, mesosphere, and thermosphere, and exosphere. These layers protect us from harmful UV rays coming from the sun. The Earth's crust and surface is the only one capable of sustaining liquid water, as the planet is within the Goldilocks zone. This is the area where life such as our own could exist. Earth's crust is split into tectonic plates that either push against each other or pull each other apart, creating volcanoes and other natural wonders. The Earth is a very active planet. As the crust pushes a tectonic plate under the surface, it allows lava to break it down. The increase in pressure force of the lava up onto surface in the form of a volcano. The Earth's core is made up of two sections. The inner core is made up of solid iron with a temperature of 4,000 degrees Celsius. It is covered by a liquid iron outer core, which creates our magnetic field. Mars is the only planet in our solar system that resembles the Earth. It has volcanoes, canyons, mountains, and ice caps. But the one problem, there's no liquid water to speak of. It's all locked up in the polar ice caps, unlikely to ever be released. The Viking space probe were constructed to both orbit the planet and land on the surface. The orbiters are still in use, but the lander has been succeeded by the Mars rover, Spirit, Opportunity, and the Mk3 Curiosity. There's Mars, red planet. Mars does have a very thin atmosphere. Overall, it's less than 1% of the Earth's. As a result of this, Mars has plenty of visible meteor impacts, as there is no thermosphere to burn up the meteors before they hit the ground. Mars' crust and surface is scarred with meteor craters. By far the biggest landmarks are the Valles Marineris Canyon, which looks like something has tried to splice Mars open, and Olympus Mons, the largest volcano in the solar system. Mars has a rocky mantle under its solid crust. Olympus Mons is being constantly fed by a fixed magma chamber, as there is no tectonic movement on Mars. The volcano stays fixed over its source. Mars has a solid iron core, which is indicated by the lack of a magnetic field. As a result, humans would have to be careful when colonizing, as solar radiation would be much higher. The asteroid belt. The asteroid belt is a ring of ice and rocks that span between Mars and Jupiter. The ring of home is the ring of rock is home to rocks, asteroids the size of houses. These rocks help maintain gravity of the other smaller asteroids. This stops the smaller asteroids from being shot towards Earth, Mars, and Venus. The surface of the rocks varies depending on the primary material. Some of the rocks are made from rocks and minerals, but some of the asteroids are made from solid ice, ranging from water, ice, and methane ice. The asteroid belt is in an area of space between Mars and Jupiter. The belt is made from numerous irregular shapes of asteroids. Of minor planets, satellites from Earth have managed to pass the belt with relative ease. Jupiter is the largest planet in the solar system, bar the Sun. It dwarfs all other planets in the solar system, but by quite a way. For a measure of scale, you can fit the Earth inside Jupiter's spot 3 times. Earth is the first planet outside of the asteroid belt, and so far the only a handful of satellites and probes have ever been there. Jupiter's atmosphere is a mix of mostly gases, hydrogen mixed with helium, methane. Jupiter's giant red spot resides just south of Jupiter's equator. It is a giant storm that spans for 4,000 kilometers and has been raging for the last 300 years. Jupiter's inner layers are mixed up with liquid and metallic hydrogen. The layer of metallic hydrogen covers the core, gives Jupiter a gigantic magnetic field, which is 1,200 times bigger than the one that encircles the Earth. Jupiter's small rocky core sits at a temperature of 35,000 degrees Celsius. And on top of that, the planet gives off twice as much heat as it receives from the Sun. If this planet was 50 times more massive, it would have started fusing hydrogen and become a second star in our solar system. Saturn. Saturn is quite an unremarkable planet. It is almost featureless gas giant, apart from the white spots appearing in 1933, 1960, and again in 1990. These spots were caused by giant storms appearing in the planet's atmosphere. The planet's rings stretch to the same distance as the Moon is to our Earth, roughly 384,400 kilometers away. Rings of Saturn. Saturn's atmosphere has almost the same makeup as Jupiter, as it makes up almost completely from hydrogen. The planet is slightly smaller than Jupiter with a massive which means that the planet has a smaller magnetic field. Saturn's layers of liquid hydrogen and magnetic hydrogen surrounds the planet's rocky core. The reason for Saturn's small amount of metallic hydrogen is that it is not as massive as Jupiter's. And as a result, the liquid hydrogen isn't compressed enough to create metallic hydrogen. Saturn's core is nearly the same as Jupiter's. It is made from iron and nickel, and it is slightly bigger than Jupiter's core. The overall size of the core doesn't help the weaker magnetic field, as the metallic hydrogen is a dynamo. Uranus. Uranus is unlike any other planet in our solar system, sitting at an angle of 97.9 degrees, which means that the planet is literally on its side because of Uranus. In 84 years orbit, each pole gets sunlight, which gives way to different seasons. Although each of these seasons lasts for 42 years, Uranus receives a little sunlight that the temperature differences between light and dark is as tiny as 2 degrees Celsius. It's on its side. That's pretty awesome. Even though Voyager 2 flew past the planet at 81,600 kilometers, Uranus is still considered to be the most featureless planet. The only way we know that the winds inside Uranus' plant atmosphere reach 300 kilometers per hour is because of some small clouds that Voyager spotted as it passed the planet. Water, ammonia, and methane layers. Unlike other gas giants in our solar system, Uranus doesn't generate much heat at all. This has led scientists to believe that this planet is not contracting. This liquid layer is believed to be the source of the planet's magnetic field, as the central point of the field doesn't originate from the core, but 10,000 kilometers outward. Uranus's core is a small rocky mass at the center of the planet. It is the only planet in our solar system which has a strong magnetic field that doesn't originate from its core. The magnetic field produced by the secondary layer of the planet is the same strength as the field created by Earth's outer core. But because of Earth's field's 60-degree angle, it doesn't have the same effect as the field that Earth has. Neptune is the fourth gas giant in our solar system. It, like its companions, also have rings of rocks and ice surrounding it. Neptune was found by astronomers after they realized that Neptune's sister planet was being pulled off course slightly. After Earth, Neptune is the bluest planet in our solar system, thanks to the methane ice clouds, the second bluest compared to Earth. That is pretty blue. Neptune's atmosphere is made up of mostly hydrogen with small trace amounts of helium and methane. The planet also has the fastest winds in the solar system, sometimes reaching 2,000 kilometers per hour. Water, ammonia, and methane layers. Neptune makes up it is very much like its sister planet Uranus. It too has a thick layer of water, ammonia, and methane, and the results are the same on both planets. The magnetic field does not originate from the planet's core, but 13,500 kilometers outward, inside the ocean of water, ammonia, and methane. Neptune's rocky core operates at a temperature of 5,130 degrees Celsius, which is a difference of 4,920 degrees Celsius between the core and the cloud's tops, which have a temperature of negative 210 degrees Celsius. Not much is known about Neptune's inner workings, as the only spacecraft to ever reach it was Voyager 2 in 1989. Pluto. Pluto is the smallest planet in our solar system. So small, in fact, that it was declassified from a planet to a moon. Later, however, scientists observed more small planets, and so they created a new class of planets, a dwarf planet. These planets are incredibly small. Pluto is smaller than our moon by more than 1,000 kilometers. Pluto's only moon, Charon, is 1,192 kilometers across, which is just about half the size of Pluto itself. Chiron orbits Pluto at a mere 19,640 kilometers, which is 20 times closer than the Moon is to the Earth. Pluto's atmosphere is only present when it is closest to the Sun, as the increased heat causes the water and methane ice to melt and evaporate. When Pluto's atmosphere is present, it is composed of methane and most likely nitrogen. Pluto is denser than that of Uranus and Neptune, meaning the planet must have a large solid core. The water ice that surrounds it doesn't melt or move at all. It couldn't at negative 220 degrees Celsius. The only change that came from Pluto's orbit is the slight atmosphere that is created by the wandering orbit. Pluto's core is massive compared to other sections of the planet. Its layers have been given the planet its mass. Because of the planet is so small, however, means that Chiron has a gravitational pressure against it. It is similar to tidal surges on Earth, but this has caused the center of the gravity between the two planets and the meaning that Pluto doesn't rotate on a fixed point. Alright. That was the information of the planets of our solar system. The solar system. That was a pretty good book.